Welcome to part 1 of the Chapter 5 practice test packet. So for problem number 1, we're given 2 trig functions, and we need to find the other 4. Well, we know that cosecant is the reciprocal of sine, so sine of x is going to be equal to negative 7 over radical 74. Now, if you look at the responses, you don't see that there. That's because this answer has a radical in the denominator. So we'll multiply by 1 to rationalize it. That means make it a rational number. And we get negative 7 radical 74 over 74. Then the other easy one to do would be tangent, and find cotangent with that. We know that cotangent is the reciprocal of tangent, so cotangent is 5/7. So because tangent is positive and cosecant is negative, we know we're in the third quadrant. So we know that's 7, that's 5. A squared plus b squared equals c squared, and that's radical 74. So to find cosine of x, remember this is the point negative 5, negative 7, we would simply take x over r. So negative 5 over radical 74. And if we do something just like we did here, we get negative 5 radical 74 over 74. And then for secant, well, it's r over x, so we get simplified negative radical 74 over 5. And that matches with answer C. Number 2, factor the expression and use the fundamental identities to simplify. So we see, I'm just going to go ahead and rewrite the problem here, that we could factor out cosine squared. And if we look at our identities, we will see that one plus, let's get that up there. And that's a plus. 1 plus tangent squared is secant squared. So this becomes cosine squared times secant squared. And we know secant squared is 1 over cosine squared. And that gives us the answer of 1. Number 3, use the fundamental identities to write the expression in terms of a single trigonometric function. Okay, so I'm going to go ahead and rewrite everything in terms of sine and cosine. But for this, there's actually not going to be any sine, because I know secant is 1 over cosine. So here, the cosine factors cancel out. We get minus 1. And for this one, we get 1 over cosine squared x. Now, if you're having problems figuring out how we got this, I'm just going to kind of do this division on the side. I just rewrote the division. 1 over cosine divided by cosine, which is the same as 1 over cosine divided by cosine over 1. Then when we change it to multiplication, we multiply by the reciprocal of the denominator. And notice we get 1 over cosine squared. And since cosine squared is the reciprocal of secant squared, we get secant squared x minus 1. Now, our identity is 1 plus tangent squared equals secant squared. But if I subtract 1 from both sides, I get tangent squared equals secant squared minus 1. So we see that this is simply equal to tangent squared. Okay, number 4, perform the addition, then use the fundamental identities. So when we add fractions, we need to have a common denominator. So what we're going to need to do is multiply both of these fractions by 1. Now the fraction on the left, I'm going to multiply by 1 plus cosine x over 1 plus cosine x. I chose that because that was the denominator of the right fraction. And then for this one, I'm going to multiply by sine x over sine x. Now, although you don't see parentheses here, these are two separate fractions, so it's going to multiply just like there were parentheses there. So 1 times 4 is 4 plus 2 cosine x plus 4 cosine x plus 2 cosine squared x. Okay, so that's the first fraction. And then the second fraction, we get 2 sine squared x. Now, I can write these as one fraction because I have a common denominator. At this point, it might be tempting to multiply the 1 plus cosine x times the sine x. I'm just going to leave it in factored form. So is there anything we can combine up here? Well, I see that I can combine the 2 cosine x and the 4 cosine x as 6 cosine x. And notice how I factored out the 2 from the cosine squared and the sine squared. The reason I did this is because I recognize that sine squared plus cosine squared is equal to 1. So I can rewrite this as 4 plus cosine x plus 2 all over 1 plus cosine in parentheses times sine x. Four plus 2 is 6. At this point, you may recognize that, oh, I could factor out a 6 from the top, which would give me 1 plus cosine x. So we get 6 over sine x, or 6 times cosecant x. Okay, now number 5 was a little tricky just because when you simplify this, we're not necessarily going to get one of these answers, although one of the answers is equivalent to that. Now, what I see when I look at this, like, okay, well, I've got 1 minus cosine x here. I know sine squared is 1 minus cosine squared x. And I know I can factor the top as 1 plus cosine x times 1 minus cosine x all over 1 minus cosine x. which gives me 1 plus cosine x. So when I look at the responses, I go, well, there's no way I can make that look like that. No, no. Well, maybe. If we split this fraction, we get 1 over secant x plus secant x over secant x. And we know that 1 over secant is cosine, and secant over secant is 1. So that is the answer, D. Okay, number 6, verify the identity. Okay. When you have sines, cosines, tangents, cotangents, it's probably going to be easiest to rewrite it in terms of sine and cosine. So cotangent is cosine over sine. Okay. So notice here we can just simplify that as sine x. So we get cosine x times sine x over sine x plus cosine x times sine x over sine x. And yes, we could have rewritten that as cosine x over sine x times 2 sine x. That would have been okay. So here we get cosine x plus cosine x, which is equal to 2 cosine x. And that will be it for part 1. We'll pick off, whatever you want to call it, start with number 7 in our next video.